one thing to know about Markov chains is that they can be completed in two different orders. One way to do them is the way that we've been doing it by using our current state as a row matrix. However, IB likes to do it as a column matrix, which they call a vector. So what we're going to do is we're going to do a little exploration and see, like, can we just swap things around, or is there more that we have to do to make this work? So I'm going to teach you about the transpose of a matrix also. Now, the transpose of a matrix is switching the rows and the columns, and we can do this manually, or the calculator will actually do it for us. So I'm going to show you that. IB may ask about Markov chain using the word vector. We haven't studied vectors yet, but just remember, for our purposes, just think of a vector as a column matrix. So a column matrix is a matrix with only one column. So A equals 1, 2, 3 is an example of a column matrix. So we're going to do a little bit of an exploration. So from the example above, what did you get when you multiplied the steady state by the transition matrix? So if I scroll back up there, it was 0.68. The next one was 0.18 and 0.14. So can we multiply T by S? So T is a 3 by 3, S is a 1 by 3. If we remember, the number of columns of the first one have to match the number of rows of the second one. This doesn't happen, so no, we cannot multiply these. So we can't just switch the order and multiply. So we can't do T times S in the way it is. So no, the dimensions do not match up. Okay, and so what I mean by that is the columns in T do not equal the rows in S. So if we try to rewrite S as a column matrix and then multiply, what do we get? Okay, so yeah, we just need a column, so we'll just switch it around. So if I go back to my calculator and I take my matrix, so it was that 1 by 3, I'm going to go over to edit it, and now I'm going to make it a 3 by 1. So it was 0.7, 0.2, 0.1. Okay, so now I've got it. So it's a column instead of a row. So now all I have to do is B times A. So if I do matrix B times matrix A, I should get the answer, right? No. So we'll notice that now I have 0.59, 0.38, 0.37. So this doesn't work. We can't just leave the transition matrix the way it was and change the state matrix around. It just doesn't work like that. So do the two equal each other? No, they don't. Now, if we want to switch the rows and columns in T, will it work? Now, we could retype it the way we did A. A wasn't hard. It was just two numbers I had to put in a different spot, and it was fine. B would require switching the whole thing around. So rather than doing that, I'm going to let the calculator do it for me. So if I go into second matrix, and I'm going to pick matrix B, and then I'm going to do second matrix again and go over to math. Now I'm going to choose option 2. That little t means transpose. So it's going to switch the rows and columns for me. So just to show you what that looks like, we can press enter. And now if you compare that to the original matrix, you'll see that now my first column, that 0.8, 0.4, 0.4, is now my first row, 0.8, 0.4, 0.4, and everything else also switched. So now I can take that transpose matrix and I can multiply it by my matrix A. When I do that, now I get the right answers again. So what happens is when we rewrite it here, okay, now the probabilities of the equipment ending up on the roof or on the floor, I think they were on the floor, sorry. The probabilities of the equipment ending up on the floor, instead of being in that top row, are now in the first column. Okay, so that's what changes is instead of the probabilities going across the rows, now they're going down the columns. So for us to use column matrices or vectors for the initial state, if the initial state matrix is given as a column matrix, such as S sub 0 equals 1, 0. So the probability it's sunny today is 1. The probability it's rainy today is 0, which, depending on the day that you've been looking at in this current month, those probabilities are probably the opposite way around. A lot of rain in April. Well, what do they say? April showers bring May flowers, so hopefully May will be great. Anyway, I digress. So the transition matrix is in the order where the columns represent the current state and the rows represent the next state. So you'll see here that now this is sunny, okay? So sunny and rainy. And you'll notice that going down, they add up to 1, okay? So the probability that it's sunny today and sunny tomorrow is 0.8. The probability that it's sunny today and rainy tomorrow is 0.2. The probability that it's rainy today and sunny tomorrow is 0.6, and then rainy and rainy is 0.4. And then I have a couple other videos set up here where you can see how you can set up the same example, one with a column matrix, one with a row matrix. So the mark scheme for the IB exam and the curriculum use column vectors to represent S sub 0. So going forward, we'll use a column vector for S sub 0, but it's important to understand both ways to do the problems because through my research, I found it both ways. So you'll use Markov chains in computer science or other math classes that aren't necessarily built on an IB curriculum. So it's important that you're familiar with how to do it both ways. So that's why I wanted to show you the row matrix way. And now we're going to move forward and do the column matrix way. So from here on, we're going to use column matrices, but it's important to understand that we could do it both ways and that later on in your college career, you may see it both ways or a row or just a column, depending on which school you decide to go to. Example 2. Bibelblatt is a new paper supplier. The transition diagram below shows the percentage of customers who choose each week between Bibelblatt and its competitors. When I wrote this example, I did not think about how many times I was going to have to say this paper supplier out loud when I chose to use the name that it had. Anyway, the first thing we want to do is we want to construct a transition matrix T with the elements in decimal form. So we're going to convert from this transition diagram to a transition matrix. So if we start with Bibelblatt, the probability we stay with it is 0.8. The probability that we switch to its competitor is 0.2. The probability that we go from the competitor to Bibelblatt is 0.1, and the probability that we stay is 0.9. Okay, so here is the Bibelblatt and the competitor, and then the Bibelblatt and the competitor. In the matrix T, state the meaning of the element. So 0.2 represents the 20% of Bibelblatt customers who switch to the competitor. And then the 0.9 represents the 90% of competitors who do not switch to Bibelblatt. C. Initially, Bibelblatt has no share of the market. So the initial market share column matrix is S sub 0 is 0, 1. calculate t times s sub 0 and interpret your answer. So let's go ahead and just drop this in our calculator quickly. So second matrix, now I have there is 2 rows and 1 column, and it's a 0 and then a 1. And then for my second matrix, it's going to be a 2 by 2. Point 8, point 1, point 2, point 9. And then I'll go ahead and multiply those together. So second matrix, I want my matrix B first because I have to do the transition and then the S, multiply that by matrix A. So after 1 week, they've now gotten 10% of the market. Okay, so that's what happens. So for part C, we get 0.9, 0.1, which means after 1 week, I'm assuming they're in weeks. Yes. So after 1 week, Bibelblatt has 10% of the market. Now we want to know their share after 2 weeks and then after 4 weeks. So in order to find out after 2 weeks, I just have to multiply this one more time. So if I want 2 weeks, I will take my 2 by 2 again and multiply it by this answer that we just got. So this is where the row matrix is a little bit nicer because the order works a little bit better for repeated calculations in the calculator. And it's not going to let me copy and paste it the way I thought it was. So what I'm actually going to, I thought I could copy and paste it. I can't. So what I'm going to do is I'm going to take this matrix and I'm going to store it by pressing the stow button in matrix C. So this is the benefit of the row matrix, is you can just keep going on and on and on in the calculator. Whereas with the column matrix, you have to either store it or retype it. And then I pressed clear instead of enter, so it didn't actually store it. So I'm going to try that again. Matrix C, enter, enter, and now it's stored. So now I can do my matrix B times my matrix C. So now after 2 weeks, so at 2 weeks, they now have 17% of the market share. And now to make my life a little bit easier, instead of storing and doing all that, what I'm going to do is I'm just going to take matrix B, raise it to the power of 4, so B to the 4th, and then multiply it by A. So that'll do my 4 weeks of transitions times matrix A. So after 4 weeks, they're up to 25.3% of the market. And reminder, we're rounding to 3 sig figs for IB. Or you can give the exact answer, so you could say 25.33 here, but 3 sig figs is good.